In this video we will look at the process of setting the geolocation using Google Maps. If we look inside the geolocation node, we will see that it uses a function called GeoAlign. The function has three parameters. The first is the latitude-longitude of the origin. The second is the latitude-longitude of a point on the x-axis. And the third is the elevation, in meters. We will repeat this process in a new model. We insert the GeoAlign function. We now need to get the latitude-longitude of our 2 points. We go to Google Maps and zoom in on the location where we want to place our coordinate system. We decide where we want to place the origin of our coordinate system. We double-click at this location to create a marker. We can then copy the latitude-longitude of the marker. We switch back to Mobius and paste the latitude-longitude into the first input box. Do the same for the second point. This is any point along the positive x-axis. We paste it into the second input box. We set the elevation to 0. When we execute the model, we will see that some attributes have been added at the top level. We can see the geolocation attribute has been created. The value is a dictionary that contains the latitude-longitude of the origin, and the elevation. In addition, we can see that a north attribute has been created. The value is a vector that points north. This vector was calculated by the GeoAlign function, based on the point on the x-axis. Now let's visualize these settings to make sure they look correct. We create a new node for generating some axes. We don't want these axes to be part of our main model. So that is why we place them in a separate node. Inside the node, we create a couple of rays. We use an inline function to make the rays. It is semantically clearer and makes TE code more readable. We set the ray to start at the origin and point in the x direction. We duplicate this line of code. We set the second ray to point in the y direction. Now we want to visualize these rays. So we insert the function to do this. We execute, and we see the two rays. Let's make the x-axis twice as long so we can see which is x. Here we can see the x and y axes. Now we switch to the geospatial viewer. Now we can verify that our coordinate system is at the correct geospatial location, and that it is rotated correctly.